you would tell me, well, it's x squared. So we use this capital F of 2x to say that is x squared. We call this the antiderivative. Anti or anti, depending. Antiderivative. The derivative of x squared is 2x, right? The antiderivative, the opposite of a derivative of 2x, is x squared. So you go the other way, like a back and forth. X squared becomes 2x, so 2x came from what? It came from 2x. Yeah? This is the beginning of what is an integral. Integration as an operation is going in this direction. So differentiation is you go from this to this. Integration, we will go from the 2x, the idea of the function, to what gave this as its derivative.
Okay.
And integration is very useful for asking or answering questions. So differentiation is answers the question, how fast is something changing? Anytime you have a question about a rate of change, how are interest rates changing? How fast is our inventory changing? How much will sales go up next year? A change? Then you're talking about a derivative. An integral, which is written using this symbol, and then a function of x dx, an integral tells you about the quantity. If you say, I'm filling a bucket, or I'm filling my fuel tank, 1 liter a minute. How long will it take to fill my tank? I mean, that's a very simple one, but that's an integral question. Now, if you're filling it and the speed of filling changes over time. At the beginning it was going fast, but the more full it gets, the slower it is. Now the rate is not constant. The integral, you can't just multiply anymore, but you can do an integral and it will give you the answer. So derivatives answer the question, how fast is something changing? Integrals let us answer the question, given something is happening this fast, what is the final amount? That's why these two things are useful.
This is our chapter on right?
Yeah, integration is, so calculus, if you say you've learned calculus, you have to know differentiation and integration.